Hello, in this video, I just would like to show you some graphical user interface of CST Microwave Studio. So when you are going to design an antenna in CST Microwave Studio, this will be the common workflow. First one will be you have to select the um, appropriate project template, which is for your simulations, like if it is for antenna designing, RCS simulation, or anything, or even if it is like EMC/MI simulation. So based on that, you have to select the project template. So once it is done, next step is you have to create that model. Then after modeling the structure, you have to do the appropriate meshing and make some modifications on the meshings to have the accurate results. After that, you have to set the boundary condition based on our solvers like open boundary or electric boundary, magnetic boundary, like that. And you also have to set the port where you are providing the signal. So this can be different types like waveguide port, lump port, so that sort of things. After that, you can do the simulation, and once the simulation is done, you can do the result analysis. So this is a common workflow. So I just would like to show you the graphical user interfaces in CST. So let's see that. So once you open the CST, you can go for new and result, and then you can check the new template. Here you can see different project template. So if you are going to design the antennas, you can always use this template. Otherwise, if it is like electronic designing, PCBs, etc., you can use EDA electronic template. And if it is like EMC and MI analysis, you can go for this. And these are also other other project templates. So if it is antenna, RCS, which is related to microwave and RF, we usually go to these settings. And here also you can see different project template based on our application. So if it is antenna, you can select this one. And if it is for radar, this will be going for the RCS calculation and everything. So based on that, you can select. So if it is an antenna, you can select these things. And here also you can see different template for based on your antenna configurations, and you can select the appropriate things. Here it will be listing which is appropriate for your simulation. So if it is like time domain or frequency domain, so we usually go for the time domain if we are going to simulate wide band structures. For a wider frequency, it is desirable to use the time domain. If we are going to use the frequency domain for the wider frequencies, it will be taking a lot of time because it will be solving the Maxwell's equation for individual frequencies. So it will be taking a lot of time. So that's why we are going for the time domain when it is wider uh, antennas, wider frequency antennas. Then you can click next, and you can check these dimensions. And then you can select the frequency here, and if you are going to select these parameters, these field monitors will be set here. So after the simulations, you can check these values in the result folder. So if you click finish, so this template name will be displayed here. So here you can see that lots of antenna project templates which I have created earlier. So once you save this, if you are going to save it as like maybe wideband antenna, maybe your projects, so you can give that name and you can reuse this template if required. So maybe if it is for any of this project for the project for the wideband antenna design, you can select this thing and then click finish. So you can use the same for any future requirements. So once you open this file, you can see that because we have seen that the workflow like modeling, simulation, result, template view, so this will be like this. So in this home window, you can see how the configuration is like. So here you can see that if which solver you have used, and unit will be displaying whatever you are selected there. So these are the settings that we have selected earlier. And this copy view, if you click on this copy view, whatever is here, it will copy that thing. And so these are to see the mesh settings. And we have the history list. I will show what the history list actually means. And here we have different macros. So these are actually the file means scripts which will which can be used for some calculation. So you can see there are lots of macros. So if you want to calculate the analytical impedance, like the impedance of the coaxial cable, you can use these macro. And there is a macro to create the port also in solver. If you go to the port, you can see calculate port extension. So this is also one important um, thing in CST Microwave Studio. And here you have the Python. So this also can be used to create the antenna models if you have created the antenna models using the Python script. Next, if you go to the modeling, here you can see that the import export function. So here using the import, you can import structures, like if you are going to do the simulation of the RCS of any two-wheeler or car, you can use this import function, and using these 3D files you can import that structure to the CST. And this background means what is set outside the modeling structure. So if it has to be like normal, because we are going to consider a vacuum space. So if you check on the properties, you can see that it's epsilon r and mu r1. So this actually represents the mm, material vacuum. So that means that we have to always set the background properties as normal. Here also you can see different uh, background properties. So if you want to change this to different atmosphere, you can change that. And this is the uh, distances of that bounding box, because we have to create a bounding box. So if you want to specify some extra bounding boxes, you can use this background properties. And this material library actually displays what are the materials which are available in CST, so which will be having all the parameters based on the material. And this one shows how the material can be modeled. So it have the brick, torus, cone, different types of structures. And we also can use this curve to create different types of polygon structures. If you want to create any structures that is not here, you can use these polygons. And these pick points are just to pick the end points and edges, like that. Mm. And once you create the model, so if you want to create any substrate, you can use this and create the structure, and based on this you can create different structures, antennas, everything. So once you set that, you can go for the simulation. So here in the simulation you can see the frequency. So here you can specify at which frequency to which frequency you have to do the simulation. So this frequency is very important, because based on this frequency the meshing and everything will be displayed. So the frequency is very important. And here you can see the boundary. So if you are going for the antenna simulations, you can always use the open boundary. So when you go for the settings of the open boundary, you can see that the open boundary condition is automatic distance to the structure. Here you can see that fraction of wavelengths. That means that this boundary is set at lambda by 4. So this is very important, to set the boundary condition as lambda by 4. here. So this is the center frequency. Here you can provide at which frequency you have to define this box, and symmetry plane. So this will actually reduce the simulation time. So if you have a structure which is like symmetric, you can provide in which dimension that is symmetric. So here you can see the boundaries like electric and magnetic. Based on that, you can set the symmetry planes. Then here you can see the different port. So these ports are actually used to provide the signal to our structure. So it can be like waveguide port, discrete port, or plane wave, etc. So here this field monitor means we are actually going to provide some signal. If it is an antenna simulation, we are going to provide some signal to the antenna, and that signal will be converted into electric and magnetic field inside the antenna. So if you want to find out the electric field and magnetic field, you can use this field monitors, and you can set at which frequency you have to see any of these parameters. And so this mesh will you can use this mesh view to get an indication about how the meshing is done inside the structures. So once everything is set, you can do the simulation. So now nothing is here. So here I have set the port. So this is one of the antenna we have designed earlier. So we have the port like waveguide port set here. So once you have set everything, you can go here and start the simulations. So once the simulation is complete, if you go for the post processing, you will be getting all the result here. So if you want to do some post processing of the result, you can use the result template. Based on the result template, also you can do extra post processing of the result. So once the simulation is complete, you will be getting all the result as 1D result, 2D result. So if it is any electric field and magnetic field, it will be displayed in 2D, 3D result. If it is like S parameters, these will be in 1D results. And if it is like far field, you can get the result here. So you can use these windows to get the results. And here we have a window known as view. So if you click any of this, if it is selected, you can rotate it. If you want to rotate in plane, it is like it will be rotated in a plane. So and if you want to pan, you can just move like this, and if it is like reset view, it will be resetting the view. And if you want to mark the dimension of the structure, you can use this option. So for that, what you can do is, if I want to mark this dimension, what I can do is I can use the pick point, then pick a end point. So here you can see that pick endpoint shortcut is P. So if you just click P, it will select the endpoint. So if you double click it, it will be selected. So I'm going to just press P and it will show this. Just click it here. And if you want to see the dimension, click on add distance dimension. So here you can see that how the distance dimensions can be added. And if you want to copy this view, so once you have designed everything and just mark everything, you can use the copy view to export this picture, and or else you can use the export image option. And this cutting plane can also be used to have the cutting display. And this is just for displaying these windows, how these windows can be displayed. So if you are doing the simulations, so whatever be the message will be coming here, and the simulation progress will be appearing on the progress window, and the parameter list will show the parameters that we have specified, and the result navigator will show what result we are seeing. So this is just basic about how the graphical user interface of CST will look like. I hope you get some ideas. Thank you.